Hey everybody, here with you another lesson on derivatives. Today we're looking at the derivative of inverse trig functions. We're going to explore where they come from and how we can use them in a lot of different problems here. So we're going to start off just kind of recalling what we mean by the inverse trig functions. Well, we call them things like arcsine or arccosine or arctangent. And what we need to understand is that they're just the inverse function of the sine. Okay, so if we're talking specifically about the sine of x, the inverse function is the arcsine of x. Another way to think of it is sine inverse of x. Now we want to make sure that we understand that it's not just the same as 1 over sine of x or the cosecant of x. Those are different functions. When we refer specifically to inverses, it's like we are switching the x and the y. So if we have y equals arc sine of x, the inverse function is x equals sine of y. And that's what we're really focusing on here. We want to keep in mind that it is a one-to-one function. So even though we understand that the sine function is the black one here, right, goes up and down and it keeps going and it continues to repeat. But when we focus on the arcsine, it's just one-to-one. So it's not going to completely reflect over that line y equals x. It's instead just going to be this portion of the graph that remains a function. All right, so that's more of a geometrical understanding of what's happening with the arcsine. And the same thing is going to be true with the arccosine and the arctangent as well. We're going to go through here a little bit of the derivation of where the derivative function of arcsine comes from. So as we said in the previous slide, if we have y equals arcsine of x, it's really the same thing as looking at x equals the sine of y. Now, we could go ahead and take the derivative of each side there. Now, this is different than what we've seen before. Normally, we see dy dx. But when we see dx dy, we are taking the derivative of x with respect to y. Right now, that's okay. We're just going to leave it like that. But eventually, obviously, the goal is to get it back to dy dx. But let's go through this little exploration of how we get there. So, the derivative of x is dx dy. The derivative of sine of y is the cosine of y. Talk about that in the trig derivative section here. Now, we could also say that the cosine of y is the same thing as 1 minus the sine squared of y square rooted. The reason for that is because we know if we had cosine of y quantity squared, that would be equal to 1 minus the sine squared of y. So if we were to just take the square root of both sides, we could see how we're getting to that step here. The next step, going from 1 minus sine squared y square rooted to the square root of 1 minus x squared, all we're doing there is we're taking what we understand about this relationship here and just using some substitution. So now we have dx dy equals 1 minus x squared square rooted. But we want dy dx. So all we really have to do is take the reciprocal of both sides. So we flip the left side, we get dy dx, and we flip the right side, and we get 1 over square root of 1 minus x squared. Now we have to keep in mind that x is only going to be defined between -1 and 1, and since the brackets are pointing out, that means exclusive. You can't include -1 and +1. And that's it. That's how we get the arc. That's how we get the derivative of arcsine. Dy dx equals 1 over the square root of 1 minus x squared. Now, we could go through this same process to look at the arc cosine. But literally, it's going to be the same substitution patterns and everything else that goes into it. So we can just go ahead and jump in and say the only difference is that we have a -1 on top. Everything else is exactly the same, including the domain as well. If you try to think of it from a more geometrical point of view, the cosine of x looks like that, and then we can continue obviously in either direction. The idea, again, we're supposed to go a little bit further there. Yeah, the negative pi over 2. But we want to keep this as a one-to-one function. So we flip it over the line y equals x because it's the inverse function, and we just have this portion of the graph when x is between -1 and +1, again, exclusive. So that's the derivative of arc cosine of x. And the last one we're going to look at here is arctan of x. So if we're looking for f, the inverse of x, when that is equal to arctan of x, that's just going to be 1 over 1 plus x squared. Now here, this is going to be a little bit different because we are going to be allowing the domain to be all real numbers. The reason for that is because y equals tan of x goes like this. So when we end up reflecting that over the line y equals x, we can go ahead and do that. We can say it's going to go on forever in that direction and forever in that direction. Now we do have some asymptotes that go into this here when we are looking at y equals the tangent of x. We have an asymptote here at pi over 2 and at negative pi over 2. So what that tells us is that when we deal with a derivative function, that is going to have horizontal asymptotes at y equals pi over 2 and y equals negative pi over 2. So that's it. Those are the derivative functions for the inverse trig functions. And we are going to go ahead and apply those in different derivative situations. So our goal here was to derive the derivatives of arcsine, arccosine, and arctangent and apply them. So that's what we'll be doing in class moving forward. And that's it. Nice quick lesson today.